Okay, so I want to just record a quick video to answer some questions I got and to give some clarification about policies for your midterm exam. Okay, so first of all, as you saw in the policies, on the exam, you may use any theorem that's proved in the notes. Yeah. But not problem sets, problems. Right, so there are some theorems that I stated as you'll prove this on your problem set, which means that we didn't prove in the notes, which means that you cannot use that theorem. You can only use theorems whose proof appear in the notes. However, there are 3 exceptions. And these are the fact that there are 3 problem set problems that appear as theorems on your number system axiom sheet. So on your number system axiom sheet, it lists 3 theorems, in particular, homework 3, number 1 through 3. These all appear as theorems there. And so you may use those as if they were proved on the notes. I will include a copy of your number system axioms as the final 2 pages of the PDF. And there will be one directly from axioms problem, which the directions will specifically say, on this problem, you may only use axioms and theorems that apply on the numbers that appear on the number system axioms sheet. And that includes those 3 homework problems. Okay, otherwise, you can't use the results of any homework problems because you are not allowed to have your homework problems with you. Okay, 2, about how to get and upload the exam. So you just go to the Gradescope tab on Canvas. You get into your Gradescope where you've been submitting your homework. And then at the time that the midterm is supposed to start, a new assignment will appear on Gradescope. It'll be called midterm exam. And you should be able to download the PDF from Gradescope. So you can try this on the old homework assignments. So I also made the PDFs available on the old homework assignments, which you already submitted. You should check to make sure that you can download the PDF from Gradescope. It'll be the same process. Also, the reason that I'm having you write the exam on physical paper is just because scanning and uploading from physical paper takes a bit longer than like outputting a PDF from your tablet. And I don't want some people to have more time than others to actually do the work of the exam. Okay, so you should do the exam in 50 minutes, and then I've left enough time for you to scan and upload your solutions to Gradescope, but it must be written on physical paper. Okay, my third point is just a word about proofs on exams. And this applies not just in my class, but in any math class. Okay, so the thing about exams is that exams are timed. So you have only a finite small amount of time in which to do problems, which means that you can write sort of a bit less thoroughly than you do on your homework. That means that you don't need to have really beautifully written sentences with nice transitions where every single thing is explained and things are referenced really well. What you need to do is you need to give all of the important relevant steps, all of them, but you can write them sort of a bit quicker. So things that you're allowed to do on exams that I don't allow you to do on homework is you can use symbols like for all and there exists and even like implies, as long as they're part of complete sentences. So your proofs still need to be incomplete sentences. They can just be written a little bit less formally. Also, every step that is important still needs to be justified. Routine computations never need to be justified unless it's a directly from axioms problem. Okay, so there will be, actually on your exam, there'll be 3 kinds of proof type things. Okay, so one will be directly from axioms. So these are like the ones on your homework. You'll have one problem like this. Again, every single step needs to be justified, but you don't need to write beautiful sentences. They just need to be sentences that justify every single step of the calculation. Okay. 2, there will be a true-false question with a couple of parts that will specifically say, like, briefly explain your answer. You don't need to write incomplete sentences, but every important step should be justified. And then there will be things that just say prove or disprove some statement. And in that case, you do need to write a proof in complete sentences, but again, you can use some shorthand. So let me give you an example of the difference between B and C. Okay, so let's prove the following theorem. let's say I asked you to prove the product of two odd integers is odd. Okay, now on a homework exercise, you will need to write the proof of this theorem in complete sentences with nice transitions, everything justified so that your reader understands. If you're doing a proof on the exam in the style of part C here, if it says prove or disprove, it still needs to be written in complete sentences, but you can use some symbols. So let me show you a nice correct proof of the standard that I expect on the exam. Okay, so the product of two odd integers is odd. So maybe we say let mn be odd integers. Okay, then there exists okay, I should say by definition of odd, there exists j, k, and z such that m equals 2j plus 1 and n equals 2k plus 1. Okay, so importantly, every variable that you ever introduce needs to be quantified, right? So here I've said that m and n are some fixed odd integers, and then I've said that there exists, and I'm allowed to use a symbol, two integers j and k. So now I've quantified those such that m equals 2j plus 1 and n equals 2k plus 1. Okay, then I say then mn equals 2j plus 1 times 2k plus 1 equals 4jk plus 2j plus 2k plus 1. Notice I'm not justifying the substitution that I'm doing. I'm not justifying, here I've used two distributivity properties, but those are just routine computations. And then I can even do this. Okay, I factored out. Notice that I've shown every step still, but I haven't justified all of the routine computations. Okay, now I want to say that mn is odd, but now I do need to check that this number is an integer, because if that number is not an integer, then I can't use the definition of odd. But all this takes is just, since 2jk plus j plus k is an integer by closure, therefore mn is odd by definition. Okay, so it's pretty brief. I've used not very many words, but enough words to make the complete sentences. I've used symbols, but but I've quantified every variable and I've explained every step. Okay, so this is what I say when I say that you still need to write in complete sentences, but you can write a bit less formally than on homework sets. Okay, what if this were instead true, false, the product of two odd integers is odd? And again, on your true, false problem, it will say something like, you need to explain everything, but you don't need to write in complete sentences. Okay, in that case, you basically just need to get every step of the logic written down so that the reader, in particular me, that I understand what you're doing, but it doesn't need to be written in complete sentences. So here, here's a nice complete solution to this. So this is false. Sorry, this is true. What am I saying? So it requires a proof. So here you could just say something, if m and n are odd, then there exists jk such that m equals 2j plus 1, n equals 2k plus 1. So mn equals 2j plus 1, 2k plus 1 equals 4jk plus 2j plus 2k plus 1 equals 2jk plus j plus k plus 1. And then on a true false, you can even do something like, this is an integer by closure. Therefore, mn is odd by definition. Okay, this is not a proof written in complete sentences. However, every step of the logic is still there. I've used lots of symbols here. I haven't written in complete sentences, like I said. But if a reader is reading along this, they can understand what I'm saying because I've shown every step. Okay, if things that you definitely need to do, as in I'll definitely take off points if you don't do it. If you didn't say that mn, actually here even I should have said mn odd integers. Okay, so if I didn't quantify, like I said, if I didn't quantify m and n, if I didn't quantify j and k, if I didn't check closure here, these things I think are things that you might not think to do, but are important. Otherwise, the proof doesn't hold up. Okay, so hopefully this helped a little bit. My main point here is that you don't want to waste time showing details that you don't need to show. So like all of these computations here, again, I've shown them, but I did not say something like, oh, by substituting 2j plus 1 for m and 2k plus 1 for n, we get mn equals this. Then by distributing 2j plus 1 over 2k plus 1, we get this. Then by factoring out 2, we get this. I don't want to see any of that because that's going to take up your time, but routine computations are okay without justification. This is actually even true on your homework as long as it's not a directly from axioms problem. Okay, so as always, if you have more questions, please post them to Piazza. I'll try to be on frequently between now and the midterm exam. Good luck studying. You'll do great.